Okay, hello everyone. Let's solve this question. Okay, the question says, disregarding all the differential lengths and imagine, okay, this object that is given to us over here, imagine that it's a part of a spherical shell and it may be described as, these are the range that are given of r, theta and phi, where surface r is equal to 3 is the same as AEHD. Okay, basically I can say this surface AEHD, it's written, it's r is equal to 3. This is r is equal to 3 and surface theta is equal to 60 degrees is AEFB. Okay, AEFB. Let's see this. This surface basically AEFB. This is what it says is theta is equal to 60 degrees. And then surface phi is equal to 45 degrees is ABCD. So basically the front face of the object. So basically this front face ABCD is phi is equal to 45 degrees. Alright. Okay, all these things are given to us. And then calculate the distance DH. Okay, we have to take out the distance DH over here. Okay, so how will we take out the distance DH? See, over here this is D and this is H. So this line we have to take out. Okay, so in this line, as we can see, it's part of the surface AEHD. So over here R will be 3. Okay, that's clear. And what else do we know? And okay, that's it. That's all that we know. Okay, let's see. Okay, DH, as you can see over here in this CG thing, it's R sine theta d phi. That means phi is variable over here. And what is constant? Your theta is constant over here. Okay, see, as you can see, the top surface theta is equal to 60 degrees, that is AEFB is 60 degrees, and we can see in our limits that theta varies from 60 to 90 degrees. Okay, that means if my top surface is theta is equal to 60 degrees, then my base, that is DHCG, will be theta is equal to 90 degrees. So that means for my DH, R is fixed to 3 and theta is fixed at 90 degrees. Okay, and my phi is variable over here in DH surface and it varies from 45 to 60 degrees. That's given in the question. Okay, only my phi is variable over here. So all I need to do is to integrate it to find out the total length. DH, that is phi, will vary from 45 degrees to 60 degrees. Okay, so 3 sine 90 degrees, and over here d phi, just simply integrate it from 45 degrees to 60 degrees. Okay, this is 3 and phi, you got this is 15 degrees. You just write it in radians. Okay, don't forget to write it in radians. When you are multiplying, you always use radians, not degrees. Then what is this you're getting? This will get cancelled and you got, okay, pi by 4. Okay, if you use your calculator, then you'll see you're getting this 0.7854. Okay. Okay, now this is the first question done. Then what is the next question say? FG. Okay, distance FG is what we need to take out. Okay, how will we take out that? See, FG over here, as you can see in the diagram, it's given as RD theta. Okay, RD theta, and it's a part of a surface. See, as you can see, the side surface AEHD is R is equal to 3, and we know that our range of R is from 3 to 5. So obviously this surface, that is FBCG, over here R will be fixed at R is equal to 5. That means my R is fixed. Let me write it over here. B is FG, and FG, as I saw, it's RD theta. Okay, RD theta, I have to integrate it, isn't it? And my R is fixed at 5. And my theta, we can see the range over here. My theta varies from 60 degrees to 90 degrees. Okay, so 60 degrees to 90 degrees, just substitute it. 5 into over here theta is from 60 to 90 degrees. All right, so it's 5 into 30 degrees and converted into radians. Okay, so you got 5 pi by 6. Okay, if you use your calculators, you'll see you're getting 2.618. Okay, this is the second bit done. Okay, then what does the next question say? Next question says surface area AEHD. Okay, AEHD, which is already defined as R is equal to 3. Over here, R is fixed. Okay, and what is the surface? This is R sine theta d phi into R d theta. I got to multiply these two in order to take out my area. Okay, area AEHD will be R sine theta d phi multiplied by R d theta. All right, so this is basically R square R square sine theta d theta d phi. Okay, and what is fixed over here? Fixed is R is equal to 3. It's already given to us in the question. Others all are variable, that is theta and phi are variable. Okay, so my theta will vary from 60 degrees to 90 degrees and phi from 45 degrees to 60 degrees. Okay, so let me substitute R's value here. So it will be 9, and instead of sine theta, after integrating, I'll get minus cos theta, and this is 60 to 90 degrees, it varies, and over here phi is there from 45 degrees to 60 degrees. All right, okay, so this is 9 into this one will be okay, this is half over here. Okay, because cos 90 is 0, then minus plus cos 60, that is half. Then this one 60 minus 45 is 15, and by converting it into radians this way, and then if you do solve this, this is 12. Okay, then if you can cut this, 3 4s are 3 3s are, so it's basically 3 pi by 8 that you're getting. So use your calculators and you'll get this as 1.179. Okay, 1.179. Clear? Then what does the next bit say? Surface area ABDC. Okay, that means the front surface, which is already defined as phi is equal to 45 degrees. Okay, let's see if we write this. How will we get it? Okay, so basically we need to take out area. No, okay, this is D. Okay, this is area ABDC. Okay, so it will be ABDC. It is, let's see, ABCD. Okay, ABCD or ABDC, anything you say. Okay, then over here, as you can see, phi is fixed. Okay, so what is this area? It's dr into r d theta. Okay, dr into r d theta. Okay, so what will I write over here? Okay, something like this, and over here r is variable, theta is also variable. Phi was fixed, but it's not written over here, so it's not needed. Okay, theta varies from 60 degrees to 90 degrees, r from 3 to 5. Clear? Just substitute the values. Okay, 3 to 5 over here. Theta is from 60 degrees to 90 degrees over here. So this is 25 minus 9 by 2. And this one is 30 degrees into pi by 180 to convert it into radians. Okay, this is 16 by 2. So this is 8 basically. This is pi by 6. So 2 4s are 2 3s are. So I got basically 4 pi by 3. Okay, and put it in your calculators and you'll get the value as 4.189. Okay, then next bit, what does the next question say? Okay, next question says take out the volume of the object. Okay, take out the volume of the object, and to take out the volume of the object we just have to multiply this and this, that is length, breadth and height, as we all know. So it will be r square sine theta dr d theta d phi. Okay, so basically volume, we need to take out r square sine theta dr d theta d phi. Okay, we know r varies from 3 to 5, theta varies from 60 to 90 degrees, and phi varies from 45 degrees to 60 degrees. Okay, so over here r square, you can integrate it individually, yeah, like this. This is 3 to 5, then this is sine theta d theta, integrated separately because these are all independent of each other. And we have d phi, this varies from 45 degrees to 60 degrees. Okay, so this is r cube by 3, this is 3 to 5, and we have sine theta's integration minus cos theta from 60 to 90 degrees, and this is phi from 45 to 60 degrees. Okay, all right. So this is 125 minus this is 3 into 3. Okay, this is 27 by 3. And this one, it's half. And this one is 15 into pi by 180. Convert it into radians. Now just use your calculators. Okay, so basically, if you subtract this, is 98 by 3. This one and this one is pi by 12. Okay, if you cut it and all, then now what is it you're getting? Okay, okay, just use your calculators. Okay, then you'll get 4.276. Okay, this was the last question. Okay, I hope you got this point that for linear, you just have to integrate once. For surface area, you have to integrate twice. Okay, you have integrated it twice, and for this volume, you have to integrate it thrice. Okay, dr, d theta, d phi, all the three, you integrated it. Okay, this is very important for holding on to your conception, so that ahead, whatever questions will come, you are able to solve it well. Okay, thank you for this video.